Hello there! Today we're unraveling the complexities of one of the most intriguing concepts in the universe, Albert Einstein's theory of relativity. Picture this, you're planted firmly on Earth, your gaze fixed on the vast expanse of the sky. Everything seems ordinary, right? But let's not forget, the universe loves to surprise us. Now imagine a rocket. It's not just any rocket, it's soaring into the vast cosmos at a speed that's almost the speed of light. As this rocket hurtles towards the speed of light, peculiar things begin to happen. Time for the astronauts aboard this rocket begins to slow down compared to those of us back on Earth. This phenomenon is known as time dilation. To these astronauts, time seems to tick away as usual, but if they were to make a return trip to Earth, they'd find that less time has elapsed for them than for their counterparts on Earth. But wait, there's more. The theory of relativity doesn't just toy with our comprehension of time, it reaches far beyond into the realm of space, speed, and perception. It alters the very fundamentals of how we perceive the universe around us, warping our understanding of reality. Let's take our imaginary rocket, for instance. This isn't your ordinary everyday space vessel. It's a symbol, a solidified version of a concept that's often hard to grasp. As this rocket accelerates, something peculiar happens. Its length contracts. Now, this might seem odd, counterintuitive even. After all, we are used to the notion that change the physical properties of an object, right? We perceive a race car zooming past us as the same size whether it's moving or stationary. But that's not the case with objects moving closer to the speed of light. At these significant speeds, the laws of physics as we know them start to unravel. Let's go back to our rocket. As it picks up speed, it starts to shrink. Not in a physical sense, mind you. It's not shedding parts or burning off material. This shrinkage is purely perceptual, purely relative. It occurs in the eyes of the beholder, so to speak. What does this mean? It means this is an illustration of a concept known as length contraction. This is a key of special relativity, a theory that was introduced by Albert Einstein in 1905. Length contraction postulates that the length of an object as observed by a moving observer will be shorter than its length as observed from a stationary point. Even though this might sound like something out of a science fiction novel, rest assured it's a reality. A scientifically proven, experimentally verified reality. To an astronaut aboard the rocket, it feels like a regular-sized spaceship. They are moving with the ship after all. Their reality is not warped by the relativistic effects of high speed. But to us observers on Earth, it appears shorter. Our perception of the rocket's size is entirely altered by the effects of speed and relativity. A fascinating spectacle of science, isn't it? Now, let's shift our focus to gravity. Einstein's theory tells us that gravity isn't just an invisible force pulling objects toward each other. Instead, envision it as a distortion, a bend in the fabric of space-time created by massive objects like planets. Objects simply follow the path created by this distortion in space-time, and that, my friends, is what we perceive as gravity. And so, we've demystified the theory of relativity. It might sound like it's been pulled straight from a science fiction novel, but it's a genuine scientific theory backed by numerous experiments. Thanks for your time today, and remember, the universe is a treasure trove of wonders just waiting to be discovered.